A widget company has a daily expense of $1,500, and each item they make costs them $1.45 to make. If they sell each widget for $3, how many, I don't know what kind of bad accent that is, but how many widgets must they sell a day to break even? Okay, well, we got something in here about expense. And then we've got something in here about, selling an item and sort of making some money. So we actually here have two equations. And there's a couple ways to set this up, but I want to identify this as two separate equations. Let's talk about the expense. How much is it costing this company to run every day? Well, every day, an expense. A widget company has a daily expense of $1,500, and each item they make is costing them, each item that they are making costs them $1.45. And now I'm using the same color for a different part of the question, so I really meant to keep all that in blue, if you can tell the difference between the blue and the purple. I hope so. So talking about the expense, relating the expense of running the company to making items, each of which has a cost to make of $1.45. So we're comparing the number of widgets, and the reason why we're comparing the number of widgets to, well, the other thing we're comparing it to is expense and number of widgets. And we're talking about that because we have a cost dealing with something per day and that cost to make each one of those widgets. So we have our cost is going to be, let's see here, I was about to write the equation, but a discussion about independent and dependent, domain and range, explanatory and response. And going back to that label of independent and dependent variable, you have an expense, you're making widgets. What is helping to determine, one variable over the other? It seems like as a company you would have some control over how many widgets you are making per day, and that value, the number of those widgets you're going to make, is going to help explain, besides the daily cost, explain how much your expense is to run the company. So the independent variable, therefore, would be the number of widgets, and the dependent variable would be the expense, or the domain is going to be the number of widgets, and the range, same different word, same type of idea, the answer, the range, is going to be the expense. So our cost, based on a number of widgets, is going to be that $1,500 per day, and that's just a one-time fee. Maybe it's a combination of your employees, your insurance, your electrical cost, renting the building, whatever is making up the expense of your company, plus that maybe the materials it takes to make each one of those widgets, which is $1.45 times, and that $1.45 is going to, every time you make a new product, a new widget, it's another $1.45, another $1.45, another $1.45, and when you do that repeated addition, that cost, that new additional cost for every widget, repeated addition, is showing up as multiplication. So we have $1.45 again times the number of widgets. And I like writing my equations, especially in early algebra, using words, even though widgets is just kind of like a generic, maybe I'm making watches, I'm making earrings, I'm making something, a widget is just sort of generic word for something that's being made. At least it's in words, and you can see that the final answer is going to be the cost for all of this production. Well, now we're going to be making money. You're selling this stuff. We're not making products. No one makes products to just give them away. I mean, I know there are giveaways, but that is to drum up more business to ultimately make it back and increase sales of something else maybe. So they're selling this product at $3 a piece, and they're trying to create an income. So what they, let's see here, let's call it income. Their income is going to be, again, based on the number of widgets these people are that we're selling, and we're doing that for $3 a piece. Every additional item we sell is another $3 coming in, and 3 plus 3 plus 3 for every one that we sell. that's going to show up as $3, again, times, because repeated addition can be sort of shorthanded into multiplication, a notation of multiplication. We have our income is 300 widgets. Now, when you talk about revenue or income, there's a gross income and a net income, or gross revenue and net revenue, whatever language you might be using. When you sell something for $3, you didn't really make $3 in profit. That's called your gross income. The net income is saying, okay, well, I sold something for $3, but there was a cost behind that. If I only sell one item, then while I may have brought in $3, I've actually spent $1,501.45 to create that one widget. So I don't want to sell one widget and just bring in $3 because I've lost a lot of money that day. So how many would I have to sell just to break even? What would my sort of gross income, my gross revenue need to be so that my net income is equal to 0? You know, when would this break even point occur? And then if we were solving inequalities, if you made or sold more than that, then you would start to incrementally make an actual net income of something, more and more values. But we're not solving inequalities, just equations. So where's the break-even point? Where does the cost equal the income? I want to be able to subtract them and get a value of 0. I don't want to lose money. Making money would be great. I'll just hopefully sell more widgets. But where's the break-even point? Where does cost equal the income? Well, by saying that, I'm actually telling us how to set up the problem. Where does the cost, 1,500 plus 1.45, and let's call it W for widgets. So when setting up word problems, it's always extremely important to define the variable. So we have 1,500 plus 1.45 W is equal to 3W, 3 times the number of widgets. Okay, so now we have to solve, really, this is an easier problem than pretty much any of the ones we've solved for so far in this lesson. We need to look for parentheses, we need to combine like terms, none of that. We need to get the variables on each, on the same side of the equation. 145 is less than 3. I could subtract both sides by 3W if I like to just always keep my variable on the left-hand side of the equation. But if I do that, there's not going to be anything on the right. And as long as you write, say, like a equals 0, then you're going to be okay. A lot of students forget to do that, though, and they just sort of move the variable in between the two numbers. So I don't really encourage my students to move their terms around in their equation to get one side to equal just 0. Not that that's wrong, but then they sort of let the equal sign float around, and that's where they kind of run into some trouble. So we're going to subtract both sides by 145W, and we're going to get 1,500 is equal to, now let's see here, $3 times $1 is $2, $2 times 40 cents is going to be $1.60, and then $1.60 minus 5 is $1.55, or $1.55. Dollars kind of makes sense for this problem because that's what we're talking about is money. And we're going to now that we got that subtraction done and we've moved our variable to the right-hand side of the equation, we need to move everything to the left. Well, we're only one step away. With our W, we have a multiplication of 1.55. So we're going to divide that 1.55 from both sides of the equation, and W is going to be equal to 1,500 divided by 1.55 is 967.7. Now, if I want to check that answer, I need to take that and plug it back into the original equation to make sure that the two sides are an exact match. Now, it'll be a solution, sorry for the static, it'll be a solution, assuming that that is a correct setup for this equation, but at least you can show that it's a solution for the equation you came up with. I'm going to pause though and just say this is a real-life application problems, if you will, and you can't make or sell, I'm assuming, 9.67 or 967.7 widgets. You need to make a whole number of widgets, and so if I want to at least break even, we need to say that W is equal to 968 widgets. That'll guarantee that we break even. Now, if you sell anything more than this, you're going to then start making a net income which is positive and actually create an income that is meaningful for your company. Got one more word problem. Bam! Bam! Last example. You travel to your parents' home averaging 60 miles an hour. Returning home, you average 50 miles an hour, and it takes you 2 more hours to get home. How far do you live from your parents, and what is the average rate of speed for the entire trip? Well, anything in motion, pretty much, especially in algebra, is going to be dealing with distance is equal to rate times time, or D equals RT. Distance equals rate times time. And you are traveling to your parents' home, from your house. So you're here at your home, you travel to your parents, you hang out, you come back, and so you're home, parents, back home. So the distance that you're traveling in each direction, assuming you have traveled the same, path, they're going to be equal. So how far do you live from home? You're going to take advantage of the fact that each of these distances are the same. So we have sort of like a D1 and D2, D sub 1 and D sub 2 here, if you will. But really, you don't even need to write them as with a different subscript because, again, they are the same length. So from home to your parents' house, your rate was 60 miles per hour, and I don't know what time is because I'm not given very much information about the time, but going this way is equal to 60 times t. And then when you head back, you go a little bit slower, so your rate is going to be 50. And now here you are being told something about the time it takes. Coming home, it's 2 more hours. Well, 2 more hours than what? It's 2 more hours than from your house to your parents. So I do not know the time that each of these trips take, but I do know something about the trip home. It was because you were going slower, whatever the time was to get to your parents, plus 2. It was 2 more than. It was 2 more hours to get home than it took to get there in the first place. Well, now I have an expression for the distance between home and your parents' house, 60t, and then getting home, 50, the rate, times time, t plus 2. And now we're just going to set these equations equal to each other, or these two expressions equal to each other, because they're both equal to the same value of d, the same distance between the two houses. So we've got 50 times t plus 2 is equal to 60t. Okay, we're going to look for parentheses that we can distribute through, and that means that we're going to distribute by the value of 50, and we get 50t plus 100, and I don't like the fact that my equal sign doesn't line up there. Sorry about that. 50 times 2 is 100 is equal to 60t, and I don't want to create any unnecessary negative coefficients. I don't really want to move terms around to leave just a value of 0 on one side of the equation, just because I see that mess up my students a little bit. And there's no reason why we can't be comfortable with having variables on the right-hand side of the equation. Just give yourself some practice. So we divide both sides by 50, and we're going to get 100 equals 10t. Now with the remaining variable, the almost isolated variable, now that we have it not on both sides of the equation but just one, we're going to undo that multiplication of 10 by the inverse math operation, which is division, and we get an answer which is that t is equal to 10. And we can assume that since we're talking about, oh, by the way, you might not understand this, mph is miles per hour, or miles over hours, and that means that our time period is 10 hours. Now, t was 10. Now, this is a word problem. It's applied to driving. Now, what the heck was t? T was the time it took you to go from home to your parents. So it was 10 hours to your parents' house. And it took you 2 more hours to get home. Well, that means that it was 12 hours to get home. Now, I'm taking some time to write some values out in terms of or in context of the actual problem, but I don't think I actually answer the question yet. How far do you live from your parents' home? Well, again, the distance from home to parents is either d, 60t, or parents to home is d is 50 times t plus 2. So really, I'm actually going to check my answer of time is equal to 10 to parents and 12 to get home. I'm actually going to check that in the way that I'm going to answer this question. How far do you live from your parents? Well, I live from my parents 60 times the number of hours to get there, which is 10. So that comes out to be 600 miles. And if I really want to make sure that this is right, after I get the phone. So again, if I want to make sure I'm absolutely correct, we said it was 12 hours to get home. So I can keep that value of t, which of course is 10, or, I have the 10 plus 2, which is where I got the 12, and 50 miles an hour times 12 hours, again, that is going to come out to be 600 miles. So I have not only answered the question, yes, in this particular problem, if this were the scenario, you live, let's see, 600 miles from your parents' house, but by doing it to both of these expressions and making sure I get the same answer, I've checked my answer. What is the average rate of speed for the entire trip? Well, if distance is equal to rate times time, and I have a question about what is the average rate of speed, get out of the way here, then I can take this equation of d is equal to RT, divide both sides by t, and this is a little preview of what we're going to be doing in our next algebra lesson, which is solving literal equations, which is an equation with more than one variable in it. We want to isolate this r for rate. We're going to do that by doing the inverse math operation of multiplication, which is division, and get distance over time is equal to rate. Now, if we're talking about an average rate of speed, that's the total distance over the total time. And the average rate of speed is not going to be an average of 50 and 60, because 50 plus 60 is 110, and 110 divided by 2 is 55 miles per hour. Our average is not going to be dead in the middle or dead center because of the time difference. We didn't drive 50 and 60 miles an hour for the same period of time, so we got to get that total distance over the total time. Well, if it's 600 miles to your parents' house and 600 miles back, that's a total distance of 1,200 miles. So our average rate is 1,200 over our total time for the average. Well, our time there was 10 and our time back was 12. So that's going to be 22. So we have 1,200 miles and a total of 22 hours, and we drove for 50 miles per hour longer, so the average should not be right in the middle at 55. It should actually be more towards the lower value of 50 because we drove that speed for a longer period of time. And 1,200 miles divided by 22 hours does come out to be 54.5 hours. And there was a lot of examples in this video. I hope that you got through them all and understood everything. This is the end of my lesson. I'm Mr. True. Bam! Go do your homework.